Yellow, yellow, hello, 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 everybody. Okay, you guys can hear me. That's great. Hopefully, you guys can hear me, right? Can you give me a thumbs up when you, if you can hear me? It'll be sweet. Today I'm back from some health problems, right? Like I was up and out. I was burned out. Got super sick over the weekend, which was good. It was over the weekend. Didn't miss much days of work and streaming, of course, right? So today I have something. Again, we are going to continue on our journey towards cybersecurity's or TryHackMe's penetration tester 1 module. Let me make sure you guys can see it, and probably you guys can't see the captions. Okay, now it should be good, right? Here as well. Okay, hopefully captions are visible for everybody, right? So as I was saying, right, we covered introduction to cybersecurity, we covered networking fundamentals. Today we will, like, what is networking at least. Today I'm going to go a bit more into LAN area network, which is a great thing because you will be able to like look at certain things and understand what is around you. And then OSI model, this actually is very important to understand because if you want, I can show you some more interesting stuff using Wireshark and to help you understand how the things is. And I will also explain you the way I understand it, like in the package manner on how like a pranking almost, which is amazing. Then we have packets and frames, again very important, and I will explain you the way I want, and extending our network or extending your network. I have been all these will help you build a very strong, or at least like a good foundation to help you with so many like softwares you will use, like Nmap, Wireshark, or even Metasploit. A bunch of these you will be able to use better and understand what's going on. And even if there is, let's say, an exploit is not working, understand where the exploit is not working, because your foundation will be good in this. And hopefully we will cover more of how the web works. Another great thing is on the weekend I will come. On Saturday I will come for a really long stream because I know I am in debt of you guys, because I was supposed to come. I was sick, could not, and Friday I have certain appointments, so won't be able to come. But hopefully Saturday and Sunday I will cover that stuff and try to go and extend as much as possible so we can work faster towards our batches and everything. So with that being said, right, give me a thumbs up if you can hear me properly, right, and you guys are ready to start this. You are already a premium member. I don't know why then it's coming. Login. Okay, it's probably logged me out. That's fine. Did it change? I don't know. Okay. So I'll just quickly, because probably I didn't log in over the weekend. The cookie inside here got expired. So I'll quickly log in, just a 2 seconds thing. Here we go. Fill. Okay, alrighty. I'm ready, daddy, do. Close this guy. Later. Okay. Should be good. Introduction to LAN, as we were there. So understanding first of all what is LAN, right? LAN is your local area network topologies. What is your local area network? Basically, let's say if you are in a university, if you are in any organization, right? Even at your home, some of you might even have some ambitions like me, where you want to set up like certain lab at home, right? Multiple computers. I can give you an example here. I have these things handy 24/7. For example, if you want to set up Raspberry Pis, a cluster of Raspberry Pis, or for your cryptocurrency or whatever, like create a farm, right? LAN area network topologies is one of the building blocks where you want to build, so you can connect all the networks such a way they are able to talk to each other, including your Wi-Fi router. That's part of your LAN area network, because think of this guy in the middle, right? We have a switch in the middle, or a networking, any router or anything, right? This guy is connected to multiple devices. One, in this case, we are shown like computers, right? But basically your laptop, your tablet, and all those things are also networking, like almost a computer, right? Your phone is technically a computer. So they are able to talk to your router. So you basically have the same topology at your home. Think about it that way, right? Remove the switch with a router, a Wi-Fi router, and you have this at home, right? And you're able to talk to each other and everything. And if you have iPhone, right, you might have seen share Wi-Fi password. How these things are able to understand what's going on and stuff. When you are on the same network, you will be able to get this image, share Wi-Fi password, when they are on the same network. That's the game. That's what's going behind, right? So hopefully that makes more sense. Star topology, we talked about this. Star topology is basically when you have like a main networking component or hardware in between. Hardware. I'm going fast on this one because we already covered this, but I want to make sure you are able to see and are able to recap. So we have a networking hardware, and like a star, right? Just like a star, there are like a star has like this shape, right? Always. So here, similar idea. You have one here, just like a star. It's like sending in all the direction. It's sending the networking data, networking information. So you will have a device 1 here, device 2. Most importantly, you need to understand these are directly connected to a networking hardware. You are not connecting device 3 and device 4 to have a communication. You are all connecting them to the networking hardware. That's how the star topology is. Bus topology, again, is a different game. Because in star, you are actually you have to get a central networking device. In bus, you don't. You actually get a cable. In this case, if I have to draw, say I will go for a very thick one. Can I make it thicker? Probably not. So what I will do a smart way. Let's say this is your networking backbone of networking and background. Let's say this is your networking cable, a big one, right? This one, and from here, you have like other cables connected, other computers connected. A big bus and things are around it, right? Device 1, device 2, device 3, device 4. Now, a lot of you might think, okay, this is like star. No, it's not. Why? Because if in star, if this is gone, no device is able to talk to each other, right? In this case, let's say if cable between here, it is blocked, device 1 is still able to talk to device 3, device 2 is still able to talk to device 4. Issue, another big issue, right? Which I think more should be a bigger focus here, is that when you are sending, let's say, packets, device 4 is sending packets, so it goes to device 2. It doesn't matter if device 3 has to send the packets to device 1, right? It doesn't matter. All those will happen all together. But in case of this guy, it doesn't happen, because in device 1 wants to send information to, let's say, device 2, all the packets are sent to this one, here, all this. Here, device 4 will send it directly to device 2, device 3 and 1 won't know. In this case, they will know, which is the issue. And if device 4 is like going hard, like an AI, almost DDoSing the whole network, device 3, 2 and 1 won't be affected. In this case, if device 3 is sending so much traffic, this whole area is blocked, device 1 can't talk to device 2 can't talk to any other devices, and device same thing with device 3. That's a issue with bus topology, right? Ring is another interesting case. Ring is basically like a circle, like a ring, right? We have a ring. I don't want to fill it with anything. Nah, don't fill it with anything. But I wish I was able to make it stronger. All good. But here, in this case, what happens is device 1, let's say, will be here in this node. Device 2 will be here. Device 3 will be here. And here will be device 4. Now, important to note, a very important thing to note, in ring, it only happens in one direction. It's not like, okay, if, let me clean this a bit here, make it device 1. It happens only in one direction. It's only one direction, because if, let's say, this part is gone, device 1, 2, 4, 3 and 2 are still connected this way, but because the flow of direction of data is only clockwise, still they won't be able to talk. So it's a very not so good in terms of like how to say it, in terms of resistance, redundancy, all those things. It's not a good method, right? And remember one thing, a lot of you might, first question, a lot of, even including me, right, when I was learning, would be like, why we want star topology, right? If there is some issue with the cable, we can have bus topology and star, we can replace the cable. A lot of companies, actually not a lot, every single company in this world would rather pay more so they don't have a downtime than pay less and have a downtime and have that issue of security all the time. And that's why there's a very technical term, like a business term called SLAs. Do look for this. SLA is basically a service level agreement. When you're going on clouds and all those things, this is exactly what they are talking about. Okay, if I go on AWS and I want their SLA for, and I'm going to use, let's say, their servers, which is called the EC2 service, I want to know their SLA. How much available in a year or in a month are there? It's mostly a year. You see, monthly uptime, 99.99%. Less than this, greater than this. They mention it. Based on which one you are using. And if this goes down, let's say if it says less than 100% and more than 99%, if it reaches, let's say 98.9, right? 98.9 or even 98.99999. If it reaches just below that, it's a lawsuit against them. You can actually get credits. You can actually ask Amazon for money in these cases. So that's why companies like Amazon and any big company would rather spend so much money so they don't have to go through this on these extra devices. So Star is your go-to guy. Switch is one of those devices, as I was saying, so things can talk to each other. Same with router. Router is at your home, the one you use for your computer, for your internet and stuff. That's your router. And we did all these things, right? Now let's look at a primer on subnetting. Important thing to note, right? Subnetting, the reason of subnetting is it's good to understand the problem first, then why it is solving, right? So if you remember, right, we had a IPv4 address, which was basically octet of 4 of these addresses, right? If you remember, 0 to 255 for each. And it was like around 4 point some billion devices with this networking. Now, even when we had like, let's say 5 billion devices and we didn't have IPv6, which was 6, but they go from like, which were way bigger, right? So before IPv6, because not every single device was capable of IPv6, we still have only 4 billion we can give. How we solve the issue of networking? Using subnets. Because if you remember here, let's say I make one house here. I'll explain you because I think subnetting is one of those concepts a lot of people struggle with. So I'll give you a really beautiful explanation so you guys understand what's going on. And you really need to understand here. So these are houses, right? Let's give this house 1, H1. Oh, very bad handwriting here. H1, H2, and H3. So what happens with case of like, let's say subnetting on internet? Let's say if you have a router or you have like the internet router. This is internet, and I'll make it something good. I'll make it white. Everything is white. Maybe not. Okay, this is internet. Let's say for example, this is internet, right? We only have 4 billion devices, 4 billion addresses. How to accommodate more than 4 billion devices? Let's say house 1 has like 10 devices, right? If it has 10 devices and this is internet, what has to do? Internet will only give it one IP address, IPv4 address. Here. It only has to give one IPv4 address, right? And let's say if it has 10 devices, they internally can have like 10 different IP address, but those will be private addresses. Private IP, right? They will have private IP and this will be one public. Same with the house 2, or let's say if house 2 is actually a home office or an office actually. I'll make this public. And let's say house this one is actually like a big organization, right? With like hundreds of devices. Let's say office Dunder Mifflin, how it is. Office 2. It will have 100. Same idea. One public IP. They can ask for multiple, right? From your, let's say, internet provider like Shaw, T-Mobile, Geo, whichever, right? Another one, they will have only public, right? One public IP address. And all the internal ones, again, will have 100 private addresses. So this is one way, quote unquote, one way they solved or were not red alarmed when the IP address shortage was coming near. And that's what the whole idea of subnetting is. Why I'm explaining subnetting? Because when you are working with your, let's say, Oracle VirtualBox, when you are working with like all these internal devices inside your home, you are doing things like port forwarding. You have, let's say, setting up a office. You want to do port forwarding. You want to have those extra stuff to get, and especially if you are doing gaming, a high good end gaming, you need to do these things. So that's what is the need or helpful and good part about subnetting, because you have 10 devices inside a house or inside office. You don't want to expose all of them. You have a printer, right? You don't want to give it outside public IP address so anybody can access the printer from the whole world. Private address, so inside your university, let's say you are in Harvard, inside in university networking only, people are able to access. So that's private address. So it has a lot of benefits, including security and stuff. I want to expose none of nothing. Bro, you are... My man is back here. But bro, here's the thing. You are already exposing it. Because if you are on YouTube, it is exposed. But yeah, you can minimize it. Right? It's interesting. You can minimize it. If you are here chatting, you have already exposed it. Yeah, I'm happy. Like, hopefully you are understanding what I'm trying to explain and how I just best would be when you next time, and this is where I think all the education I'm trying to give, all the information would be successful when you see next time something like this, right? You go to an office or something, you see IP addresses and you are able to tell, okay, this is a public IP address and private. Because a beautiful thing I want to explain to you, private IP addresses, right? And public IP addresses, there is a list. So, and it's called CIDR of private Oh, no worries, man. I like these things, right? You have no idea how much I like these chats and like a shit poster. I love it. Don't you worry. No need to say sorry. But I want to share this thing with you, and you might have seen this, right? 100% you have seen this, if not yet. What's that? I set up OpenSense and Zen Armor to keep the baddies out. Baddies, that's a nice word for hackers. That's so funny. I've never seen somebody use that word for hackers, man. That's hilarious. But yeah, I want to explain you this thing, and you might have seen this thing. 192.168.0.0 or .1 or .2. Your router, a lot of your people, your home router, right? Go down and check its home address. That where you want to like change its password or all those information. A lot of time it's 192.168.0.1 or .2, but majority of that time, right, if you go to your companies or universities or anywhere, you look for the printer's IP address, it would be starting with 172.10 or 192. Majority of the time that's how the case is. So do go check out your router and everything, like any internal device, check it out. Like your router, check out your printer's IP address, right? Or if you go to university or something, check their IP addresses. You will see it. It's 100% there. So hopefully this is helpful. What's that? I want to understand how DHCP and IP assessment work for the ISP. How do their gateway get assigned IPs and how do they assign my modem? That's a beautiful question. So DHCP, for people who don't know, this is like the protocol help to give you a private IP address inside your house. An IP assessment, internet protocol assessment with either your internet service provider and stuff. And he's asking specifically DHCP for ISP. That's a good question. I never. I want to. Let's see what this guy has to say for us. Because I know inside how it works when we are inside our house. I never thought of like outside. That'll be an amazing question to ask. Similar to whom? Yeah. Like it has to be similar because it's the same protocol. But I want to see how in the global world it would be cool. Right? Explain in simple words and steps how DHCP and IP assessment work for the ISP, as well as how do their gateways, how do ISPs gateways get assigned IP addresses, and how do they assign IP address to my modem? That's actually a beautiful question, bro. I would love to understand this. Did it went for a pro one? Oh, okay, it went for pro search. All good. Okay. How DHCP and IP assessment work, ISP to your modem. Understand how your internet devices gets an IP address involves two main steps. How ISP get and manage IP addresses and how does addresses are assigned to your home network. Understandable, right? First, how the internet providers are getting it. ISP, for anyone who don't know, is internet service provider. These are the people you pay your internet bill to. How ISPs get and manage IP addresses. Global pool of IP addresses managed by Internet Assigned Authority, IANA. Okay, Internet Assigned Authority. I have no idea. Oh, I can. I know I can. That's for. Okay. So IANA is the one that gives or manages IP addresses and goes to Canada and other companies. Locates large bulk of IP addresses to regional internet registries, RIRs, which then give smaller blocks to ISPs. So Above ISP, there is some RIRs. Okay. Let me search for Canada's perspective. Copy. In Canada, 5 regional registries, African portion of Indian Ocean, portions of Asia. Okay. Erin, so Canada, many Caribbean, North Atlantic islands, and the United States. Okay. So this is for America region only. Latin America, Europe and stuff, which are gone there. Okay. Okay, so these are different regions, not just America, but the website is. That's amazing. Okay. Your ISP receives a range of IP addresses from the RIRs. For example, a small ISP might get only 4096. That's big still, but they just gave like, oh, it's a small one, 4000 IP addresses. How ISP gateways and your modem get IP addresses. So hopefully this is clear, right? How ISP get to manage their IP addresses is because multiple organizations above who manages internet are given IP addresses, then some lower one and so forth. So how ISP gateways and your modem gets IP address. So ISP gateway assignment. ISP uses parts of its assignment IP block for its own network infrastructure, including its gateways, routers that connect the ISP to the wider internet. Yes. These gateway devices are usually assigned IP addresses manually, static assessment, or via internal DHCP server, depending on the ISP setup. So first, gateways are assigned, I will say, okay, manually, IP address by the ISPs. And then when they connect to the internet, your modem communicates with the ISP's network. ISP typically uses DHCP to automatically assign an IP address to a spool of your connection. Okay, the assignment process works like your modem or router send a DHCP request to ISP through the wire, whatever, as it connects. ISP DHCP server picks an available IP address from a spool, leases it. Same, I think, yeah, like you were right? So just like in our home, our phone wants to connect to our router. Using DHCP, available IP addresses gets one. ISP system often ties this lease to your modem MAC address. So your MAC, there is a, if a lot of people don't know, even in your router, there is a table, very simple table with MAC addresses and your IP address. Simple. Because your MAC address doesn't changes. You can spoof it, but it technically doesn't changes. If you unplug your modem for a long time, your IP might change when you reconnect because that pool is different, like IP address is gone and stuff, right? The public IP address is assigned to your router. Your modem itself doesn't get a public IP address, it just passes the connection to your router or computer. Yeah. Sounds good. So basically inside the router also there is same thing, right? So hopefully this explains, right? This is actually good one. So global assignment, INA, RIR to ISP, ISPs to their gateways, then the gateways to our modem and modem to our computer. That's actually a good question. Thanks, bro. That's actually a good question. I never knew about these big organizations. Yo, you guys can even like look for jobs here. I hardly think anybody looks for jobs here, right? Do you think there might be jobs here? Because these organizations, nobody applies for jobs, I believe. I hardly is through certain Indeed and stuff. I wonder if ISP gateway devices are vulnerable similar to home network devices. I'm sure they have more controls, but things like DSP. Oh yeah. That's a good question. That's actually like might be the way to hack internet at one point, right? Like if you want to hack internet, might be a good way to look into. And I'll just make it like this so everybody can see the messages and my face and the caption is not a problem. Sorry, I'm just aligning it properly. What's the last one? I'm playing around and notice the ISP gateway device I'm connected to had port 20 open and returns a login prompt for FTP. That got me wondering how the system works higher up from. Oh, that's dope. That's dope. Yo, bro, that's sweet. That's sweet. You know what? I'm after this. I'm also looking into this. That's amazing. Actually, that's a good one. Yo, you brown paper bag. I don't know. Is there a? Do you want me to call you brown paper bag, or do you want prefer a different name? Might be easier, like whichever you a nickname or pet name you have. But that's actually amazing to look like. Even if we can take down the internet, that'll be cool. That's actually good. Thanks for the question, man. Amazing, amazing. Brown or bag or paper or Mr. Bag. I'll call Mr. Bag. That's cool. Hopefully, Mr. Brown. Mr. Brown is good too. Mr. Brown. And I can't be held racist because I'm brown too. You can't call me racist in this case. I reported it to my ISP, so I don't think they cared. Yeah, those companies. The majority of the companies, not going to lie, even from my past experience, because I'm not going to name the company because I might get into very bad legal troubles for certain reasons. But there was a company that got hacked. I did mention to someone with power that you could get hacked because of this exact reason. They didn't listen. And when they got hacked, actually, interestingly, just a couple months after I told them, the hacker was in their network for months, and their security boom, like hiring of security architects, engineers, like all I could see for like 2 pages of LinkedIn was just that. It was like 20 plus jobs within one day. So I think that's the biggest problem with the whole culture of organization and the government. If companies, if you want companies to take care of your security and all these things a bit better, one thing is we have to pressurize government to make better laws. That's all. And this is okay. Now it's working. Cool. But I think like that's culture. You have to force the government to make sure stricter culture is there for the organization and more incentive is there for organization to take security in their hand. Yeah. But with that being said, let's look into a primer on subnetting with DHCP and all these things, right? With the knowledge. As we have previously discussed throughout the module so far, networks can be found in all shapes and sizes, ranging from small to large. Subnetting is the term given to splitting up a network into smaller miniature networks within itself. The thing you are getting, the gateway, your ISP getting 4096 IP addresses, for example, is kind of subnetting. It's kind of subnetting because it's dividing network into small parts. Think of it as slicing up a cake for your friends. There is only a certain amount of cake to go around, but everybody wants a piece. Subnetting is you deciding who gets what slice and reserving such a slice for this metaphorical cake. So here, the bigger the ISP, the bigger the cake they get, more addresses they get, right? Take a business, for example. You will have different departments such as accounting, finance, human resources. True. So internet, routers, switches. We have accounting, computers, human resources, and finance. Whilst you know where to find information in real life to the correct department, networks need to know as well, right? Because if you want to send a package or a check, if you are the CEO, send the check to the head of HR. You have to know which department, which building it is. Network administrators use subnetting to categorize and assign specific parts of a network to reflect this. So in a big organization, let's say level 1, right? Office on level 1, floor number 1 is HR. Then above is accounting and above is tech, stuff like that. Subnetting is achieved by splitting up the number of hosts that can fit within the network, represented by a number called subnet mask. Let's refer back to our diagram from the first room where it is like, IPv4 address 0 to 255, 0 to 255, again same thing, 4 octets. As we can recall, an IP address is made up of 4 sections called octets. Let me know if I'm going too fast. I'm just because a lot of things we covered with the chats we had, right? And all those things. If I'm going fast, I can go slow. Or if it is good, like give me a thumbs up. That will help me. maintain the speed. The same goes as we are here. As we can recall, an IP address is made up of 4 sections called octets here. The same goes for a subnet mask, which is also represented as a number of 34 bits ranging from 0 to 255. Just like I was explaining here with my image. Where is it? Did I clear everything? No. Okay, I think I cleared everything maybe. Okay, no, here. Okay, so I was saying, right? Probably down here. No. But I was just, you probably saw it, right? Like we have like 3 houses, one here, one here, one here. All of them are connected to a gateway and all are given one IP address. Inside, if there are 10 devices, subnetting happens where those 10 devices also get IP address. Same concept here. This is that concept, I mean. Subnet use IP addresses in 3 different ways. Identify the network address, identify the host address, and the default gateway. Let's split these 3 up to understand their purpose into the table below. Network address. This address identifies the start of the actual network and is used to identify a network's existence. For example, a device with the IP address 192, remember I showed you 192.176 and 10. So here 192.168.1.0 will be on the networking identifier by this. So here networking identifier starts, the first one is the networking identifier. This is a device. So this here 192.168.1.0, that's your networking identifier. An IP address or host address, an IP address here is used to identify device on the subnet. This is your device itself, like your phone, your router, which you probably go, if you look at this 192.168.1.1, go on your computer or your phone, try this, or even 0.1. Depending, or you can just go on your router, right? You will see this. Example, a device will be on, have the network address of this. Example is this, right? Because here, this is the device, this is the network address. Default gateway. The default gateway address is a special address. This is important to know. Designed to a device on the network that is capable of sending information to another network. Gateway, think about this. If this is your house, right? There are multiple people inside, right? Let's say it's you, your dad, your mom, and your sibling. Your dad, think of, for example, it's your dad or mom, right? Who can go outside the gate and take the information of the whole world, or like get information you need, come back. Same, or this special person, right? And every single person, imagine them as a networking device, right? So this could be your phone. This is your router. This is, let's say, your computer or your laptop. This is your home, like smart home device, like your watch, Apple Watch, right? So your router is the gateway. It's given a special address so it can talk to the whole world on the internet and bring information to your laptop, to your watch, or to your phone. Now read it again. The default gateway is a special address assigned to a device on the network that is capable of sending information to another network. Another network being internet. Internet is a network too, right? Any data that needs to go to a device which isn't on the same network, isn't on basically this network, right? Hey bro, I retail you with another. Yeah, sure, go for it. So yeah, I'll complete this and then I'll take your question. Any data that needs to go on a device that isn't on their network, it can be another house, another country, another continent, will be sent on this device. So your router. These devices can use any host address, but usually use either the first or the last host address in a network. 154. So remember, let's say I can go, right? I have a network, right? It can go from 1 or 0 actually. It can go 192.168.0.0 and it can increase. How it will increase? This is same, this is same, this is same. It will increase to 1. This will go to 2. Same thing. It will be 0 here. Okay, one sec. Sorry. Oh, my apologies, lads. Okay, so just I will make it much better. So this will be 192. Just like your street address or your home address, right? The address next to your house, right? It doesn't have a different city name, doesn't have a different country name. It has a different house number. Same idea here, right? So this 3 goes till 254. So 254, the last one is always the gateway. First one is always the networking address, and in between you will have your device addresses. Hopefully that helps. How can I make a new internet? How can you make a new? It basically like you have an internet inside the house. Because think about this, right? Think about this. Creating a new internet, let's say creating a new miniature golf course, right? Right? Simple idea, like hopefully that makes sense, right? Or like even let's say just take example of internet so you don't get confused. This is a whole internet, right? Wait, what happened? Oh, it didn't show my previous message. Oh, you typed something, did you? Wait, how come is that? I know there is no checks on YouTube for this. Is there any? I don't think so. Oh, it didn't show your previous message. Okay, interesting. Because I know on Twitch I had certain controls I was playing with. YouTube, I don't think so. How the internet sucks now, but it's not sending it. There is AI in the wire, bro. There is AI is taking control of your freedom of speech. Welcome to 21st century. The one AI is going to be a reason of our extinction, who knows. But yeah, and weird. I don't know if you guys know the weird meme from that Snow White, Snow White. I always love making this sound every time I'm talking to someone. Weird meme. Hold up. Where is that video? I have to pull the whole video or what? It's probably this one. No.
Absolutely viral. All you have to do is impersonate she's making. Going viral. Here's the original Snow White to go up.
Never mind. Okay, all good. I don't know where. Snow White. You're right. Like it's zapping your comments. Wow. And I just know this one. I just
Hold
love.
on, before you.
Let me just block this for a second.
You're crying on that stage.
When am I not crying in public? It's so upsetting.
Why were you crying?
Oh my gosh, I saw the screen and I just wanted to throw up.
Here.
Super enjoyed.
What do you mean by that?
I just mean that it's
Not going to be
yeah,
saved by the
37, and we absolutely wrote a Snow White that is
not going to
On stage. What do you mean by that?
super enjoyed.
I don't know. I'll just quickly show. I want to show you this
You
thing.
were bringing a modern edge to it on stage. What do you mean by that?
I just mean that it's no longer 1937, and we absolutely wrote a Snow White that is
not going to be
yeah,
saved by the prince.
She's not going to be saved by the prince, and she's not going to be dreaming about true love. She's dreaming about becoming the leader she knows she can be, and the leader that her late father told her that she could be if she was fearless, fair, brave, and true. And so it's just a really incredible story for, I think, young people everywhere to see themselves in.
Snow White is running for president.
I have no idea. Okay. I can't find that meme. I just, this weird, wherever it is.
I just mean that it's no longer saved by about
No White in the movie
She's not going to be dreaming about true love. She's dreaming about becoming.
There is a Disney.
She can be. So weird, weird,
Weird. I just love saying that. Sorry. But yeah, like it's zapping your comments. Can you put it in the Discord? You have my Discord, right? I want to see it, what it is. This is the Discord, right? Like here. Let me know once you send it. I will check. But yeah, like things are like, it's interesting. A lot of these quote on gore. Oh, you send it on X? Okay, let me check. Send it on X. Okay. No. Nope. I have so many. Oh. Okay. Do it on Discord if possible. I have so many messages. And majority of them are actually like scams of like, oh, the next big thing or next Bitcoin. I will be honest with anyone here. Do not ever invest in a cryptocurrency or any currency that doesn't have a big community and transaction going forward, or an organization that backs it very well. But yeah, till then, I think we can go. Let me know once it is there, right? And I have chess and all these things. You guys can tell what I do in my free time. 112 1132. That's my ranking right now. Trying to make it to 14 or something. Good number. Yeah. Take your time. But yeah, for everyone else, right? As I was saying, for internet, if you want me to ask a quick explain how to create your internet, right? Basically, you need a addressing method. Let's say if we are using the same IPv4, right? First, you need an addressing method, right? A protocol to send it, assign everyone an address, just like a house. Just like if you in your house, you want to send information using post from one house to another in the whole world, right? Same idea. You have a environment, right? A ecosystem. You have multiple devices in here. 1, 2, 3, 4, 5, 6, 7. Now you can tell them whatever protocol you generate, let's say IPv4, a way so that they all can talk to each other. This is actually such a bad method. A way they can talk, like a central point, right? They all can talk to each other and you have your internet, basically. If you want all the information of internet, you just need to buy really big NVIDIA related information or like databases to set up at your house. But yeah, that's in a nutshell. If you want, a lot of people do it. Like I think there is a very beautiful video using pfSense. Somebody created a pfSense internal or home lab. Back. One of the videos I saw, I think maybe it was Homelad creating a PS server, something like that, in which you use like one of the frameworks outline where you are creating a firewall so nobody else in the world can talk inside you without your permission and create a network. And buy these great Raspberry Pis just for the testing, because then you can use it for different purpose. Have your Mario, like I used one for RetroPie. RetroPie is like if you are into 1980s games, RetroPie is the software. Oh, you send it? Okay. I'll just want to show RetroPie. I love this software. Use it to play Contra and couple of other things. Yeah, this is an amazing website. So everybody do check this one out. This is amazing. Okay, so let me check let me quickly refresh. I didn't get it. Messages, no. I built a open sense router firewall on Intel NEC for my home internet, but I am dreaming of a future internet with no bots or billionaires. Oh, on Discord, okay. Okay, howdy. Ban Mark Zuckerberg. The internet's SA now, and it just gets worse. It's controlled by a smaller and smaller group of S companies that exist to sell your data more and more. Is filled with bots as well. 100% is filled with bots. I assume, is it because of the S and S words, like the words you use, that's why it got taken down? Interesting. But yeah, I agree. It's a bunch of bots. It's a bunch of like people, just very few people controlling it. Yeah. It's just a bunch of people who are controlling. Give me 1 sec. I have to put my laptop on charge. 1 sec. Okay, sorry, I had to put my laptop on charge. That's how I'm able to monitor the chat. Okay, but yeah, man, this is the world we live in. We are the one who basically didn't care. Oh, no worries, it's all good. I just created the swearing rule because there is a lot of kids who want to learn cybersecurity, are passionate about it. So for those reasons, I don't mind. It's because of those. Sorry, I ran up and down. Okay, now let's focus on this and get it. Now, in small networks such as at your home, you will be on one subnet, as there is an unlikely chance that you need more than 254 devices connected at one point. True. However, places such as businesses and offices will have much more of these devices like PCs, printers, cameras, sensors, where subnetting takes place. Subnetting provides a range of benefits including efficiency, security, and full control. You'll come to explore exactly how subnetting provides these benefits on a later date. However, for now, all we need to understand is the security element of it. Let's take the typical cafe on the street. This cafe has two networks. One for employees, cash registers, and other devices for the facility. One for the general public to use as a hotspot. If you might have seen this actually, like when I go to Tim Hortons or Starbucks, there is Starbucks private and Starbucks public. And that's where, like, if you sniff the stuff and you're able to do Wi-Fi hacking, you can see what's going on. And those transactions, the Interact transaction, the Visa and MasterCard, that's what goes on your private ones, or maybe the SIM card. Through SIM card they do it, cellular. Okay. Subnetting is allow you to separate these two use cases from each other whilst having the benefits of connecting to a larger network such as the internet. What is the typical term for dividing a network up into smaller pieces? Please answer this. I would love if I can hear some answers. So, technical term to divide a network into smaller pieces. How many bits are in a subnet mask? How many bits? Remember that. Remember, this is CIDR. So, how many bits? One of the answers will be segregation. Are you sure? Segregation. No. We talked about this. I said that 1,000 times. What is the range of the section of octet of a subnet? You probably know this. Octet, what is the range, right? What address is used to identify the start of a network? What address is used to identify devices within a network? What is the name used to identify the device responsible for sending data to another network? Really good questions. I'll start going over, right, and see. So first one will be subnetting, bro. Subnetting is the technical term dividing a network into smaller pieces like internet, right? How many bits in a subnet mask? Wait, so subnet mask, let's say if I have 10.0.0.0 and I want to have 32 bits, probably. Yeah. What is the 32 bits for people who don't know? This octet, right, is actually like zeros and ones. This is actually like 8 bits. This one is divided into 8 bits. This is something, a good thing to look into, how this 32 changes this. What is the range of the subnet octet? This is, I will put some things as homework so you understand on your own. So, but this one is 255 because 256 is not possible, right? Technically, there are 256 numbers, 0 to 255. What address is used to identify the start of a network? I think default address. What address is used to identify devices within a network? Oh, this is not default. What is the answer for this? Name to identify the device responsible. Gateway. Device. This one is gateway. Here it should be, right? Network address, okay. And default gateway. I got those things mixed up. Network address, and this one is host address. I'm bad with the names. Can't change that. I forget so many names all the time. Okay, but this is good. Now, Mr. Brown will look into DHCP after this. ARP is a big one. I want to explain you because ARP is something you guys can see in your home network. And do I want to show you? Probably not. I will show you through my Oracle, the virtual box, but not through my actual one. You can tell what I'm using and all those information. So come on. This is good. Host address, come on. Okay, host. I keep on typing wrong. Host address. Apologies, lads. Okay, I'll just refresh this page so it's faster loading probably. Log in again. Okay, I don't know what's happening here. TryHackMe does this all the time to me. Okay. We're back. ARP. ARP is a very important one. The reason I'm saying this because you will use it if you're building a home lab, right? This will be a very important protocol, and you can use this when you are even like, let's say, inside a network as a cybersecurity or ethical hacker. You are inside, you want to see all the devices that are there connected to the same Wi-Fi network, same Wi-Fi router, right? That device you are on, this will help you. Recalling from our previous tasks that devices can have two identifiers, a MAC address and an IP address. The address resolution protocol, or ARP for short, is the technology that is responsible for allowing devices to identify themselves on a network. So basically, this is the way a device can tell, okay, this is me on a network, right? Like your iPhone can tell, okay, this is me. Your watch can tell, okay, this network belongs to me. Simply, ARP allows a device to associate its MAC address with an IP address on the network. MAC address is basically, let's say if you have a car, there's like an engine address, right? Which is like hard coded, which is like cannot be changed. It's the same for a network interface device on your computer, on your iPhone, on your iWatch, wherever, Apple Watch, right? It's hard coded. Each device on the network will keep a log of the MAC addresses associated with other addresses. So when you are on basically in your house, right, you have your let's say phone, you have your phone. This will have addresses. Let's say there is one, there is device 2. Let's say this is your TV, this is your iPhone or phone, this is your computer, and this is your router. I'll keep router as something special. All these devices, right? All these devices will have a list, a table, if you may. What the table looks like is basically, if this is a table, it will be your another system, including yours, every device's MAC address plus the IP address, the private IP address in their room, right? So it's your iPhone's MAC and IP private, computer, router, same TV, whatever, yada yada yada. And you can look at it by just typing the ARP command, which I'll show you in a second. When devices wish to communicate with another device, they will send a broadcast to the entire network searching for the specific device. The devices can use ARP to find the MAC address and therefore the physical identifier. Physical, remember, just like your engine in the car is physically hard coded, same idea. So MAC address of a device for communication. So if my computer wants to, let's say, talk to the iPhone to get, let's say, using, iCloud or whatever, get some information, or same vice versa, they can request, okay, what is your MAC address? And it will record in this table. So they are communicating, it's easier. How does ARP work? Each device within a network has a ledger to store information, a table basically, which is called a cache. In the context of ARP, this cache stores the identifier on other devices on the network, identifier of the other devices on the network, basically their MAC address. In order to map these identifiers together, IP address and MAC address, ARP sends two types of messages, ARP request and ARP reply. Just like TCP, right? Same idea. Basically, like ARP, why ARP request and reply? If you are asking a question, if you are asking me a question in English on chat or anywhere, right? You expect a reply in English. The same concept. You are asking in a protocol, ARP protocol, you are getting a response in ARP protocol. When an ARP request is sent, a message is broadcasted on the network to other devices asking, what is the MAC address that owns this IP address? When the other devices receive the message, they will only respond if they own the IP address and will send a ARP reply to this MAC address. So basically, your iPhone will say, hey, or your phone will say, okay, which IP address belongs to this, this, this. When it finds for the phone one, that's it. The requesting device now can remember this mapping and store it in the ARP cache for future use. This process illustrated with diagram below. So we have, this is how the MAC address, and this is source MAC address, destination MAC address. Let me make it clear. Source MAC address, destination MAC address. This is how it looks, right? Total 6. MSG, who message basically, who has an IP address of 192.168.1. So there's computer, webcam, and this all three gets the message. Only the switch or the router sends it back. I have the IP address this. So what is the what does ARP stands for? Let me know answer. This one I know. Oh, thank God. What category of ARP packet asks a device whether or not it has a specific IP address? So ARP request response, which one of them? What address is used as a physical identifier on a device on a network? Please answer this. What address is used as a logical identifier for a device on a network? Logical versus physical identifier, big differences. So first one is address resolution protocol. What category of ARP packet, right? That ask is the request one. What address is used as a physical identifier on a device? Physical is MAC address because it's hard coded, right? What address is used as a logical one? IP address. Remember, IP is the one that helps in logically differentiating whether a computer belongs to a HR department or a tech department or accounting department. So logical. Now DHCP, this is what everybody uses, they just don't know, right? So this is where we'll take a deep dive. IP addresses can be assigned either manually by entering them physically into a device or automatically, and most commonly by using a DHCP protocol. So when you connect your device to somebody's router, including your own, you do not assign a IP. It's done automatically using dynamic host configuration protocol or a DHCP server. It's in your router. It has this. When a device connects to a network, if it has not already been manually assigned an IP address, it sends out a request to see if any DHCP servers are on the network. The DHCP server then replies back with an IP address the device could use DHCP offer. So there's DHCP discover protocol or request, DHCP offer. The device then sends a reply confirming it has used, it wants the offered IP address, DHCP request. And then lastly, the DHCP server sends a reply acknowledging it has been completed. The device can now start using this IP address, which is acknowledged. So DHCP discover, offer, request, acknowledge. Here, discover. Hey there, I want an IP address. Do you want to use this IP address? Sure. Okay, you can use it for next 24 hours, 3 days, whatever. Yada, yada, yada. What type, and important to note, you might be thinking, why would you do manually when something is being done automatically for you? Let's say you have a web server on your house. Inside your house, right? You are setting up a server. Then you want a proper IP address so any service on the internet can look exactly at that IP and the port and all those information. That's how it works. What type of DHCP packet is used by a device to retrieve an IP address? First one, DHCP retrieve an IP address. First is discover. What type of DHCP packet does a device send once it has been offered an IP address? It has been offered. So first is discover. Second is, I forgot, then request and then acknowledge. Second one was DHCP discover. What was the second one, lads? Offer. DHCP offer. What is the last DHCP packet? So it's acknowledge. Okay, now we can continue to the OSI model. Let's look in this. OSI model is how the internet is, how things work on the internet, and you will use it more often than anywhere. I love how it is like in a Mario Kart way or Mario way. It's set up layers, 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 right? Let me drink some water first. Are you ready for OSI or you want to take a break today? What is your guys' intuitions? We can cover this fast. It's not that hard to understand. So let's just do it. If nobody has objections, let's just get it done, okay? The OSI model, Open Systems Interconnection Model. Interconnection, open systems, remember that, is an essential model used in networking. This critical model requires a framework dictating how all network devices will send, receive, and interpret data. One of the main benefits of OSI model is that devices can have different functions and designs on a network while communicating with other devices. Data sent across a network that follows the uniformity of the OSI model can be understood by other devices. Basically, this is how, let me explain, let's go over, I will explain you with a very beautiful way how I think of it and how I learned it. But basically, it's a framework detecting how all the connected devices will send, receive, and interpret data. And every single layer, right, has a different function and design related to it so that the devices can talk to each other in a uniform manner. The OSI model consists of 7 layers, which is illustrated in the diagram below. Each layer has a different set of responsibilities and arranged from layer 7 to 1. 7 being application, then presentation, session, transport, network, data link, and physical. At every individual layer that data travels through, specific processes take place, and pieces of information is added to this data, which is what we'll discuss in the upcoming task within this room. However, for now, we'll only need to understand that this process is called encapsulation and what OSI model looks like in the diagram below. So important thing I'll explain you how things work, right? We have 7 layers. 1, 2, 3, 4, 5, 6, 7. Hopefully you guys can see this. So we have 7 layers, right? Okay, I can't type 7 properly. 7, 6, 5, 4, 3, 2, 1. How things work, right? If I'm sending a packet, information, right? Let's say a letter to someone, right? They are following the same method. So what happens? Let's say if a data I'm sending is hello. This is the data, right? It enters layer 1 and one packet like this hello information is covered with something. So let's say if this is hello, this is my data. This encapsulation happens and this data is covered with some extra information at layer 1. Then it goes to layer 2, same thing happens. Gets covered with more data at layer 2, same thing happens at layer 3, right? And so forth. It keeps on adding some extra piece of information that is very useful, but that's how the data is being transferred. And when it reaches another system, what happens? Decapsulation, where the last one is gone, then the one above, because it's going from up to first 1 to 7, then 7 to 1. So information keeps getting removed, right? Whatever is this? This gets removed, then this gets removed, and at the end you see data. So that's what happens at OSI model. So we'll explain in layer 1, 2, 3, all those things. They will go a bit more detail. But this is what happens, so you don't get a bit more, like overwhelmed with the idea. So this is simple. It's simple, just written in such a way. Open system. I thought it was open system. Isn't it open system or systems? How many layers are there? 7, right? What is the key term for when pieces of information gets added? Encapsulation. Okay, so now let's look at layer 1, the one that is at the bottom, physical layer. And if you're in university or if you're looking into tech, this is very important to learn, every single layer. This layer is one of the easiest layer to grasp, but put simply, this layer references the physical components of the hardware used in the networking, and the lowest layer that you will find. Devices use electrical signals to transfer data between each other in a binary numbering system, ones and zeros. For example, Ethernet cable connecting devices such as picture below. So basically your Ethernet cable, right, any kind of physical cable, right, that's data, that's physical data going through in terms of currents and whatever. That's your layer 1. Zeros and ones is your layer 1. What is the name of this layer? Physical layer. What is the name of the numbering system that is both zeros and 1? Binary. 0 and 1 you need to understand. Not get like scared of it. It's just 0 and 1. What is the name of the cables that is used to connect devices? Ethernet cable. There's so many other ways to connect, but Ethernet is the one used most. Okay. So Ethernet cable, and we'll write things down as we are going. So I will type Ethernet physical. One sec. Physical. This can't be extra large. Holy, this is small then. This is Ethernet cable. Right, your physical layer. Simple. Sorry, it takes time. I just get a bit like this. Next is the data link layer. And even your Wi-Fi router things that are going, that connection, that's physical layer. Data link. The data link layer focuses on the cable of the router, I'm saying. That is physical. The data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, including the IP address from the remote computer, and adds it to the physical MAC address. Okay, this is, I think, you know what, the best way is, I'll go from layer 7 because I think they are not doing it in the proper job. Let's see if this one works. So the application layer, the layer 7. Application layer of the OSI model is the layer that you will be most familiar with. This familiarity is because the application layer is the layer in which the protocol and rules are in place to determine how the user should interact with data sent or received. So how are basically like what you are seeing on YouTube, that's application layer, right? Every day, applications such as email clients, browser, and file servers, file server browsing software such as FileZilla provide a friendly GUI, graphical user interface, for users to interact with data sent or received, right? Other protocols include DNS, which is how you are able to use google.com instead of remembering an IP address, which is how website and addresses translate into IP addresses. So layer 7 is basically how your data, this is what I was saying, your data is layer 7, right? So we'll move from up and down, up to down. Application, this is your email, etc. How you interact, right? So layer 7 is application. The technical term that is used for the name of the software that users interact. So your GUI. That's another term you will get very familiar with, so no need to worry. Layer 7. Now layer 6, presentation layer. Layer 6 of the OSI model is the layer in which standardization starts to take place. Because software developers can develop any software, such as email client, differently, the data still needs to be handled in the same way. So your Outlook, your Gmail, right, your Hotmail, your Yahoo Mail, if you are crazy, all these, right, they are different, they look different, the GUI is different, their application is different, but at the end of the day, they are emails. So no matter how the software works, they have to be a certain standard. This layer acts as a translator from data to and from the application layer. The receiving computer will also understand data sent to a computer in one format destined for another format. So data sent from one computer, even though they are different computer, because they are standard, like English, right, is standard, so one person can talk to another. Standardization, one computer can talk to another. For example, when you send an email, the other user may have another email client, right? Like I can have Outlook, you can have Gmail. I can have Outlook on computer, you can have Gmail on a phone. The content of the email will still need to display the same. Security features such as HTTP, right, hypertext, which you see on the website, when visiting a secure website, occurs at this layer. So this one, applications like here, let me email clients. Because HTTP is how all the websites in a standard way show everybody data, right? So this one is presentation layer, and this one is all about standardization, right? Like with website, all websites talk HTTPS or HTTP, basically say S is for secure. Presentation. Say this is the main purpose, standardization. Main purpose of this layer act as a standardize. or translator, right? That's also same thing. So presentation. Why this is not done? Name of the layer, presentation again. Okay. Hopefully you guys are understanding this, right? You guys are able to understand what I'm saying and trying to do. Does it make sense? Like where we have emails written, right, using Gmail or what. Here, standardized in an email SMTP protocol. A protocol is used. A standard protocol by all the clients and everything, right? You guys get it? Any questions so far? If not, let's move forward with our session layer, right? Session layer, once data has been correctly translated or formatted from the presentation layer, session layer will begin to create and maintain the connection to other computer for which the data is destined. So if I'm sending data, right, or email, I want to send it to the Outlook server. So this will create a session, or like you are going on Amazon, it creates a session, right? A session Docker, similar idea. It creates a session so that the data is able to transfer, you are able to shop properly and all those. When a connection is established, a session is created. Whilst this connection is active, so is the session. So once you close your browser, session is done. You create a new session when you again open the browser. Same idea. The session layer is also responsible for closing the connection if it hasn't been used in a while or if it is lost. Additionally, a session can contain checkpoints where if the data is lost, only the newest piece of data is required to be sent, having saved the bandwidth. What this means, it's very important because one, for example, let's say you are downloading a big game. You might have seen it at BitTorrent, right? BitTorrent, let's say, is divided into small chunks. The whole movie, the whole game is divided into like, if it is a 1 GB, is divided into, or 100 GB, it's divided into 1 GB each, right? So what happens with the session? Let's say if something is downloading, it clears this one, it clears this one, clears this one, and here. Now the connection fails, right? What if session layer was not a thing? It will start again from here. All this work, all this here things you did, this will go to waste. This was still internet use, right? This was still data on your present. So what session does? It still keeps this and it starts from here after your connection is returned. So you can start getting more back. You can start from there. That's how a session is created. Can contain checkpoints like, okay, 40% is done, that's the checkpoint, where if the data is lost, only the newest pieces of data is required to send, saving you bandwidth, right? What is worthy of noting is that sessions are unique, meaning the data cannot travel over different sessions, but in fact only across each session instead. What it means, different session, like if I have Amazon open on Chrome, let me go back. Amazon open on Chrome, right? This session cannot be used on Firefox. This session won't be used, right? It cannot be used in different session. Firefox and Chrome will have their own session, but Chrome, right, this is not allowed. But Chrome, when the session is expired, all that information still can go to the next session, only each session instead, right? Same session keeps going, increasing. So here, this is the session layer. Connection session is the same, right? Okay. Transport layer. Transport layer, layer 4 of the OSI model, plays a vital role for transmitting data across a network and can be a little bit difficult to grasp. When data is sent between devices, it follows one of the two different protocols that are decided based upon several factors: TCP and UDP. So TCP and UDP, you might have seen this protocol all the time, but what these protocols are is basically when you are doing a video call using WhatsApp, when you are sending email, anything. TCPs and UDP are the way to help you address, to tell, okay, send this information, this video call or this message to my mom's phone. How it will find your mom's address? Using this protocol, using this technology. Let's begin with TCP. TCP, Transition Control Protocol, potentially hinted by the name, this protocol is designed with reliability and guarantee in mind. So, for example, you send a message, an email, TCP, so that it doesn't get lost. This protocol reserves a constant connection between the two devices for the amount of time it takes for the data to be sent and received. Not only this, but TCP incorporates error checking into its design. Checksum error. That's the technical term. Error checking is how TCP can guarantee that data sent from the small chunks in the session layer, the one before, has been received and reassembled in same order. So the data, the game you were downloading, is done in a proper way, right? It's proper. Like if, let's say, during the connection lost, this also got lost and it's not done properly, this chunk will also get downloaded again. That's how TCP work. Let's summarize the advantages and disadvantages. Guarantees the accuracy of data because you want to play the full game, right? Some part of game is gone, some code is gone, you can't play it. Requires reliable connection between two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used, right? Capable of synchronizing two devices to prevent each other from being flooded with data. So if this part is gone, it won't like keep sending all this again. It will only send from here onwards. This one won't be. A slow connection can bottleneck other devices as the connection will be reserved on the receiving computer. Same idea, it won't like keep on sending you. There's a whole system. It will send you, but it won't be like, okay, sending you again and again. It's synchronized. Perform a lot of processes for stability. TCP is significantly slower than UDP because more work has to be done by the devices using this protocol. So TCP is used for situation like file sharing, internet browsing, sending email, because those has to be done properly. For example, YouTube, right? That's also TCP. This usage is because these services require the data to be accurate and complete. Not having half a file doesn't make much sense. Like some part of game is gone. Doesn't make much sense how you will play a game. If the diagram below, you can see a sending of a picture of a cat, right? Web server, packet 1, packet 2, packet 3, the final packet, and that's what you see. Now let's move on to UDP, User Datagram Protocol. This protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast that many features offered by TCP, such as error checking and reliability, but you have seen this and you use it. And I will show you how. In fact, any data that is sent via UDP sent to the computer, whether it gets there or not. There is no synchronization between the devices or guarantee. Just hope for the best and fingers crossed. WhatsApp. You're talking to your mom. I'm talking to my mom or dad, right? I'm on there, right? WhatsApp. Some of the packets get lost. I don't even know. Like sometimes I say something like because of the connection, data is lost, right? So that's what happens. And depending on what you are using, depending on what's going on, right? Or what type of service you want to offer, both have its advantages and disadvantages, right? UDP is much faster, right? Faster video call. Leaves the application layer to decide whether any control over, because it doesn't do any checksum or anything. Does not reserve continuous connection. So if the connection is lost, the call ends. TCP, the call won't end. UDP doesn't care if the data is received, right? Some part of the video is lost. You have to ask what they said again. Flexible to software developers. This means that unstable connection result in terrible experience. So you need good internet. So here, example like this, the cat picture is gone in the middle. UDP is useful in situation where there are small pieces of data being sent. For example, protocol used for discovering devices, ARP, DHCP, all these, as we discussed in room 2. Or large files such as video streaming, where it is okay for some part of the video is pixelated. Like we are talking on video call, right, on WhatsApp. Or just pixelated is just lost piece of data. What is the name of this layer? Transport. Because here we are transporting, we are addressing. IP addresses are on this layer. That protocol is here. Transportation. TCP transfer. Transportation, right? Transmission control protocol, okay. Transmission, I'm bad with names, man. Control protocol. UDP is Datacom protocol. Unified? No. What is U in UDP? What protocol guarantees accuracy? TCP. What is U? User datagram protocol. Okay. What protocol doesn't care about data? UDP. I'll show you a meme. I will end with a meme, right? What protocol to help you understand? What protocol would an application such as an email client? Email, if I send to my manager, I want it to be received. So TCP. What protocol would an application that downloads files use? Downloading based, it can be any UDP or TCP, right? But I would prefer TCP because I want to see the whole file, right? So TCP is a better choice. What protocol would an application that streams video use? Mostly UDP, right? But for example, YouTube, you might want this all in one. So we covered these ones. Let's cover 2 and 3 tomorrow, including the OSI game. So we can move towards pockets and frames. I have some work I have to get done. So thank you so much everybody joining, and let me share the last meme ending this so you understand TCP and UDP for the rest of your life. This is it. This is how things work. This is not a great image. Okay, this is a good one. So if you ever see, right, data, sender and receiver, right, they are handling properly. Imagine this. So with that being said, a big thank you to everyone, especially Mr. Brown, right, for helping me and asking great questions. For anyone, feel free to join my Discord and ask me any questions you like, right? I will just drop this link for Discord. And if you have, again, any questions, feel free, or especially if you have any feedback for me, please let me know. And like our tradition, but somebody said to ask this, and I should ask this for my stuff. Like, share, subscribe. That's all. But for me, most importantly, have a great day, pay it forward, and love you. Thank you, everyone. Like usual, bye. Bye, everyone. Have a good day.